Hi, everyone. So, home automation. Who's tried some home automation at home? Okay, a couple of people. All right, cool. So today I'm going to tell you all about my home automation experiences. But first, before I get there, let me introduce myself. So my name is Gergana, but I usually go by Jerry because that's a little bit easier to pronounce. And that's my website over there and my Twitter handle at the bottom if you want to take a look. And I work here at BBD in the research and development team. And a lot of people ask me what we do in the research and development team. And the plain, boring answer is we do a bit of research, obviously. We facilitate the training of the BBD developers and the rest of the staff. And we also do some specialized consulting. But that's kind of the boring answer. We also do a lot of fun stuff. We do things like build meme generators, fly drones with bananas, and my personal favorite, program astromech droids. This is pretty much how I started out. I got one of these little robots about 4 years ago or so, and I got bored of the app that it came with, so I started hacking it with JavaScript. And I did a bunch of talks on that, and I quickly became known as that Star Wars robot girl. But after that, I've also hacked a bunch of other droids and electronics and things like that. Some slightly more successful than others, as you can see from this tweet. Right, so I carried on hacking things and robots and all kinds of stuff, mostly with JavaScript. But one day, my husband asked me, what about me? So I had done all of this stuff. I had hacked so many things. I've even written tutorials on how you can do home automation at home. But none of it was for me. Even those things, those famous wine button that some of you may have heard of, is not actually in use. It just sits in a cupboard. It's not even plugged in. So I decided it was time to do some of our own stuff. And I decided I would start with our garage doors. Now, our garage doors are a little bit weird. It may be me, but sometimes when you push the one button, the wrong door opens. And so our motors are just messed up. Maybe I just pushed the wrong button, I don't know. But a lot of the time, our garage doors stay open in the middle of the night. And we have this really friendly neighbor who likes to tell people on our WhatsApp group when the garage doors are open, because it happens to the rest of our neighbors as well. And we laugh about it all the time, like me and my husband laugh about it all the time. But it's actually kind of nice of him to do that, because you want to close your garage door. Except when you're in bed in your pyjamas and you're warm and it's winter and you don't want to go downstairs outside to close your garage door. So that's why I decided to start with the garage doors. And to do that, I decided to use Mozilla WebThings. Mozilla WebThings is an open source implementation of the Web of Things. Now, before we can get to more about Mozilla WebThings, we need to talk about the Web of Things and what that is. But before we can talk about what the Web of Things is, we need to talk about one very famous buzzword: the Internet of Things. This has become one of the biggest buzzwords of our time. And we hear it all the time. And it's here to stay. It really is. It's the idea of connecting absolutely everything, from people to buildings to cars, everything from a smart computer to a bottle, to a smart network so that they can communicate and share data with each other. And this is a great idea. It seems like a good thing to do. And if we think about the computing power we have available to us, it should be possible. But why haven't we achieved it yet? We have so many smart things, but not everything is smart. Why? Well, because we have a number of problems with the Internet of Things. The first one is fragmentation. If we think about one single sensor, that sensor's data is not useful to us. We need to combine a whole range of different sensors into one device and make that device smart. That means that we need to understand how all of those sensors work, how to connect them together and how to make them work. You need to understand different technologies to get that working. Then we have protocols. Anyone who has ever done anything to do with IoT has heard of the MQTT protocol, right? But that's not the only protocol out there. That is the most popular one used for IoT. But we also have AMQP, which is used by Windows IoT devices. Now I know what you're probably thinking, does anyone really use Windows IoT? Yes, they do. Okay. Then we have Weave, which is used by Android things and Linux devices. And we have HomeKit, which is used by iOS devices. Now, in order to be able to connect to all of these different things, and these are just the popular ones, there's actually hundreds of protocols. In order to be able to connect to all of them, we need to understand how these protocols work, and we need to understand how to program for these protocols. Next, we have connection methods. We have Wi-Fi, Bluetooth, NFC, all of these different wireless connection methods that we can use. We can't just support one of them. In order for everything to be smart and everything to be connected, every physical device, we need to be able to support all of the different connection methods, which means, again, we need to be able to understand all of the different connection methods and how they work. And if anyone has ever looked into how Bluetooth works, you'll know that it's not easy understanding these connection methods. And lastly, security. A friend of mine and I were talking a little while ago, and he said to me, do you know what the S in IoT stands for? I said, no, there's no S in IoT. What are you talking about? And he said, yes, there is no security in IoT. Take a look at this headline. This is not a joke. I promise you can go to that URL. It's not a joke. It actually happened last year. So hackers managed to hack into the thermostat of the fish tank sitting in the lobby of a casino and extract data of all of the high rollers in that casino back out through the thermostat into their database. I'm not joking. I'm not joking. It's an unnamed casino. They obviously don't want to release who did it. But security is hard in general. Often for us as programmers, security is an afterthought. But in IoT, we're in uncharted waters. We don't actually know how to do security for IoT. We haven't figured it out yet. It's too new. So all of these things, the promise of IoT is actually amazing. It sounds really cool. It sounds so futuristic. But if we don't overcome all of these problems, there's no way we're actually going to achieve it. This is where the Web of Things comes in. So the Web of Things is a W3C standard, and it concentrates on the fact that a lot of these things have already been solved on the web. If we think about our years of experience on the web and all of the protocols and standards we've developed, we want to apply those in the same way to IoT. Let's take HTTP, for example. HTTP is a universal way of transferring information between different machines. And it's been around for a long time. It works. That's exactly what the Web of Things is, but for physical devices. It's a way of connecting absolutely everything in the physical world to the World Wide Web. Even the security problems on the web have been solved. I know not a lot of people actually implement security in their web applications and therefore cause a lot of vulnerabilities, but we know how to do it, which is the important part. The formal definition of the Web of Things. The Web of Things is a refinement of the Internet of Things by integrating smart things not only into the Internet, but into the web architecture. What this really means is it's a high-level application protocol designed to optimize interoperability of the Internet of Things. So in order to get a bit more of an understanding of what the Web of Things is, we need to talk about its architecture. And this architecture was designed in such a way so that we can organize all of the protocols and standards of the web, and we can connect them to actual physical devices. It's a layered architecture, and it has 4 layers. The first layer is the access layer. This is where we convert our things into web things. Okay, so we're going to take RESTful API design principles and make the data available from the devices on the web over HTTP. That way, our data is available in JSON format, and it's easily readable by the web. But now you're thinking, garage doors. I don't want to query an API every single time I want to know whether my garage door is open or closed. I want to know real time, right now. Well, we use another web protocol, WebSockets. It notifies us all the time whether our door is open or closed. Now that we have our data, what's next? Well, we need to find and understand the devices and the services they provide. For that, we use web semantic standards to describe the web things. Again, we use JSON to describe what the thing looks like, what services it provides. And I'll show you that a little bit later, how it actually looks in the JSON. But that would make it searchable in search engines, as well as easy to create user interfaces for. Layer 3 is about sharing. IoT will only be a real success if all of the devices are able to share data and information security. This layer is responsible for exactly that, defining how this can be done efficiently and safely. For example, we have TLS to encrypt our data. We know how to use TLS. We can encrypt the data of our devices so that it's transferred securely between the web and the device. We also have things like OAuth and OIDC, which can make sure that only the correct people have access to certain data. It's easier to secure things on the web because we've solved these problems previously. And we can also share this data on social networks because it's available on the web. And lastly, we need to bring all of these things together into large-scale enterprise-level applications so that we can reuse all of our physical devices on the internet. We need to be able to read the data from these web things and expose the services to analytics software and mashup platforms so that we can use them properly. Node-RED is a great example of this thing working as it's supposed to be. So this entire architecture is outlined in the W3C specification, which has already been accepted into the web standards. And there's a whole bunch of other specifications that the Web of Things working group is working on to help with each of the different layers related to the main architecture so that it will make it easier for us to connect everything to the web. In short, what we want to do is achieve a decentralized Internet of Things by giving every single physical device a URL and making it discoverable on the web. So now we can talk about Mozilla WebThings. As we said earlier, Mozilla WebThings is an open source implementation of the Web of Things. Mozilla is big on the standards of the W3C. They will implement everything that gets standardized. All right, inside their browsers, inside anything. And it comes with two things, a gateway and a framework. The framework is a collection of reusable software components, so you can build your own web things. So you can take any device and code for it to make it a web thing available on the web via a URL. It will then become discoverable by the WebThings gateway, or it will also be discoverable by any client that's configured to look for things on the web. Now, at this point in time, I've been talking a lot about web, and I keep mentioning the word web a lot. But I would like to point out that this does not actually need a working internet connection to work. It can just work on a LAN. So it uses MDNS to discover the devices that are connected to the same network and make them available on the gateway, which is pretty cool because I haven't had internet for the last 2 weeks, and I've been playing with this stuff anyway. The WebThings provides libraries. WebThings framework provides libraries in a number of different languages. Depending on your devices, you can code them in Node.js, Python, Java, Rust, Arduino, whatever device you have. And the nice thing about it being all open source is that you can also create your own third-party libraries. So there's a bunch of third-party libraries that exist as well, such as the C# library and a few other languages as well. Depending on what language you prefer, you can use that. Then we have the WebThings Gateway. The WebThings Gateway is just a web app. And it's there so that you can directly monitor and control your smart home over the web without having any sort of middleman, without needing a Google Home or an Alexa or a home, what's the Apple one called? I forgot. That one. It comes with a bunch of things. Firstly, a user interface to control your devices and monitor them. A rules engine so that you can automate the interactions between all of your different devices. And also a whole bunch of add-ons so you can connect it to existing devices. So one of the add-ons that I'm planning on using is the Chromecast add-on. So you can cast directly to your Chromecast with the WebThings Gateway. Again, it's open source. So if you can't find the add-on for the device that you want to use, then you can make your own add-on and submit a pull request. Now, the way you get the WebThings Gateway installed is you can either just download the repo from GitHub and just run npm install, npm start, and you have it running. That's how I have it running at home. We have an old media center computer, and it just sits there running the gateway for us. Now, if you don't have that option, you can also get the Raspberry Pi distro and flash it directly onto an SD card, put it into a Raspberry Pi, and that will run it for you. The WebThings Gateway is also a PWA. I haven't tested this feature, but it does mean that you can install it on your phone as an app. So it might provide some cool offline capabilities as well. It's a cool option. So for my demo, I was going to set up this really cool thing where I was going to set up the cameras at home so that they would look at the garage doors, and I was going to open the garage doors and from here at home. But then we didn't have internet for 2 weeks. And we got internet yesterday. However, I wasn't going to risk the internet dying again today because I didn't trust it very much. So I decided that I should bring all of my things here, and we can pretend that they're opening and closing garage doors. Okay. So this is what all of this stuff here is. We have a reed switch, which is how most garage door sensors work. You can come check it out afterwards. And a magnet to close and open the reed switch. We have a relay for closing and opening the garage doors. And we have the LED, which lives inside the house to notify me that the garage doors are closed or open. So let's go over here. So over here, this is the repo. Just zoom in a bit there and clear that. So if you have a look, this is just the repo exactly as downloaded from GitHub. I have run npm install already because I don't want to sit here downloading the entire internet while you wait for me. So I'm just going to run npm start. While that starts up, I wanted to show you something else. This here is the URL of the LED. It's not loading right now, so I'm going to stop that. And you can see the JSON format it provides. The name of my LED device over here is called warning light. It's an on-off switch because I want to be able to turn the LED on and off, and it's also a light. And all of its properties can be found at this URL. All of its events can be found at this URL. And the alternate here is the WebSocket URL, which is pretty cool. Now, the first time you start up the WebThings gateway, it asks you to create a URL for yourself. And it actually, you put in an email address and it registers a certificate for you. And that becomes a URL that's accessible from anywhere else.
So it generates a unique certificate for you. I was going to ask you, so secure out the box.
Yeah. It does. It generates and it sends you the information to confirm your email and everything. So mine is created already. I just want to make sure it all started up correctly. So, and it's just whatever name you choose, .mozilla-iot.org. And that's accessible from anywhere. And this is what the gateway looks like. You can see we don't have any devices as yet. So I'm going to click the plus button and hope that this all works. It's not working. So sometimes this does not work. Oh, wait, it's getting there. All right, it's picked up the door sensor, which is the read switch. Come on, please work. Okay, I'm gonna try restart everything. Just bear with me for a second. If it doesn't work the second time, I will just show you the video where I recorded the demo. Okay, close that. Close that. It's going to work this time, I promise. You know, I usually think that when I record the demo, it's going to work when I do it because I have a backup plan. But, you know, it doesn't always happen. Okay, MDN is started. Okay, let's go to. Okay, let's hit this here. Opened new thing socket. There we go, it found all three of them. All right, cool. So you can see we have, and one of the cool things here that I wanted to point out and why I needed to find all three of them is, so the relay and the door, even though they're attached to the same actual device, they come up as two different sensors because that's how you can set it up as two different devices. So that's pretty cool. And the door, you can set as a door sensor, save that. The warning light, we can save that. And the relay, we can save that. All right, so that's going to refresh there. So you can see our door is currently closed. If I move the magnet away, our door is open. If I put the magnet back, our door closes. And if I push the on-off button, the light turns on and off. But now we need to actually make this work together, right? Because I mean, it's fun blinking LEDs, but what's the point if it's not going to turn on? So this is where we use the rules engine. And the rules engine needs a little bit of work, but it's okay. I might submit a couple pull requests. So we add the door sensor as the input and the warning light as the output. If the door sensor is open, we want the warning light to turn on. And we name our rule, door is open. Cool. And then we add another rule, because it's different rule. If it's not open, then the warning light is off. Cool, and this one is going to be called door is closed. Alrighty, and both of our rules appear. Now if we go back to our things, And if we remove the magnet, our light turns on. Yay. Put the magnet back, and our light turned off. Cool. The relay sensor I can't really show you, but when you hit it, it just turns on, and it pretty much makes the garage door open or close.
Do you have your broken remote in?
It's in the car. Anyway. Alrighty. Oh, and wait, there was one more thing I had to show you. Sorry. There's a really cool thing where you can upload a picture of the floor plan of your house and put all of your devices in the different parts of your house, so you can see exactly where they are in the house. And then the add-ons are over here. You can see, you can add on a bunch of stuff, a bunch of different things. There's a whole lot of different ones you can find in here. It's really cool and really easy to set up. And I think it only doesn't work when you make your own WebThings devices. It works a bit more reliably if you're using ones that have been created by other people, because of my C code, mainly. Alrighty, cool. So this is where I've started. I only have garage doors for now. I'm planning on automating more things in the house, so keep an eye out on my Twitter if you're interested to see more. And the last thing I wanted to talk about is the W3C standards. With standards like this being taken seriously on the web, that whole idea of the IoT, of connecting absolutely everything to networks, is becoming a possible thing. We're soon going to have the IoT that we deserve. Thank you.